Welcome everybody, and thanks for joining to the new learning session from the Parity Delivery Services team. Today we are going to talk about a very well-known pallet. This is the pallet balances. It might be not as complex as other pallets, but it doesn't make it less important. Actually, it's very difficult to think about a parachain or any kind of chain that is using the frame substrate, the substrate frame, without using this pallet, especially because it's interconnection with the frame system. We'll talk about it later. This is today's agenda. I'll start talking about the pallet main purposes, high-level features. Then my colleague Dominic will start talking about dependencies with other frame pallets, how it's used in Substrate. Then it will be Alex's turn. He will walk us through a demo, showing us some of the features I previously talked about. And finally, a code walkthrough. There will be two Q&A sections, one right before the code walkthrough and the other one right after. Pallet main purposes. So the first one is probably the one that everybody's thinking about. The simplest one is to manage issuance and accounts balance of a native asset. To explain this feature, I'll have to go through these three concepts: the TotalIssuance, imbalance, and currency. TotalIssuance and imbalance. TotalIssuance is a storage item that keeps track of the total supply of the native asset. Total supply is calculated as an addition of all account balances. However, TotalIssuance is not always up to date. Some operations can cause account balances to change, producing an imbalance between the TotalIssuance and total supply. Therefore, we can say that this is what we are looking for, like a total supply match with the TotalIssuance plus imbalance. If the balance is 0, then we are expecting that total supply is equal to TotalIssuance. Let's explain this with an example. Let's imagine that we have this initial state where we have a chain with a TotalIssuance of 1,000 tokens. The total supply is also 1,000. And Alice is one of the accounts with 200 tokens. So in this initial state, TotalIssuance and total supply match. But for some reason, Alice gets slashed. What would happen here? So Alice's account, we see how it drops to 0 because the whole amount it's been slashed. And then this slash function returns an imbalanced object with 200 tokens. What will happen with the total supply? As we said before, the total supply equals to the addition of all accounts, because Alice balance was reduced by 200. Total supply is also reduced by 200. What do we do with the imbalance? Okay, remember we are looking for having same amount in total imbalance and total supply. We will see a couple of options. The first one is to send to the treasury. So we send that imbalance to the treasury account. What will happen with the total supply? The total supply will be increased accordingly. Remember, total supply equals to the addition of all accounts. And we don't have to touch the TotalIssuance. And they both are equal. Everybody's happy. Another option is to burn it. It's like, okay, I don't want to do anything with those 200 tokens. But in this case, we have to take care of like updating the TotalIssuance. And then the same. They are equal. Everybody's happy. Currency. So this is the simplest trait implemented by pallet balances, where its operations return imbalances. This trait depends on two associated types that implements the imbalance trait. You have the pallet positive imbalance that denotes that funds have been created, or like minted is the same, without an equal accounting. A negative imbalance denotes that funds have been destroyed or burned without any equal accounting. This is the widely used by the other pallets in frame. to update accounts. Free balance and TotalIssuance. Remember about this, the free balance, because we'll see later how the balance is more complex. There are more attributes, not only free balance. The most common methods of the currency pallet are mint, burn, transfer, and slash. There are other trades also that return imbalances, and they do this because they require the currency trade. So let's take a look at it. Are these three trades: reservable currency, named reservable currency, and lockable currency. We'll talk about them later. But what I want you to see here is how they implement also the currency trade. So they can use all the methods that the currency use, so minting, burning, etc. But also they implement their own. For the case of reservable currency, reserve and slash reserve. In the case of named reservable currency, it's similar, but it has like an ID, so the methods changes. Reserve name and slash reserve name, and lockable currency, set lock, extend lock, and remove lock. The next main purpose, it's control when an account exists. To understand how it works, I'll have to go through the concept of existential deposit. But first, to understand existential deposit and the rest of types of the trades I'm going to explain afterwards, we have to understand what's the main struct where the balances are stored. It's called account data. It holds all the necessary information related to accounts balances. It's formed by four attributes. The first one is free. That's the one I told you to remember. So basically, it's controlled by the currency trade. So this is only modifying this one. Then we have the reserved. It means the balance that still belongs to the account holder, but it is suspended. You have the miscellaneous frozen, the balance that free cannot drop below, with the exception of transaction fee payments, and then the fee frozen, the balance that free cannot drop below specifically for transactions fee payments. So, for example, if we had like a balance with an account data where the fee frozen is 0, it means like you'll always have available. Not available. I mean, your free. You can use always your free balance to pay fees. Total balance. When we talk about total balance, it's a free balance, this one, plus the reserved balance. What's existential deposit? So, if an account exists or not, is controlled by existential deposit. This a constant defined in the runtime, sets the minimum balance an account must hold in order to exist. Therefore, if an account total balance, remember, free plus reserve, drops below the existential deposit, the accounts get ripped. What does it mean? So ripping an account means removing all information from where it was stored. It's usually done in the frame system pallet, removing the account ID key from the account's storage item. Subsequently, not only the balances data is removed, also other important information, including the account's nodes, which is set back to 0. So we'll see this later in the code walkthrough. So this is the how are both pallets strongly interconnected, the balances and system. Basically, the balances data is stored in the system, in the frame system. And finally, the next and the final purpose is to control requirements for minimum balances. For that, I'll explain what reserves and locks are. So reserves is a storage item that keeps track of reserved data objects in a map where the key is an account ID and the value is a list of reserved data limited on number by max reserves. So basically, imagine this is like a stack where you start like a pushing reserved data. That reserved data will keep information about your reserve, and it cannot grow beyond the max reserves. Max reserves is like, it's also like a constant that is set in the runtime. We'll see it later also. The reserve data struct is formed by ID, an identifier, and the amounts you want to reserve. Reserve data objects can be added, removed, from this reserve storage to the list from other pallets through the implementation of the traits reservable currency and named reservable currency in the pallet balances. Their methods will take care of updating accordingly final reserve attribute from account data. Requires the currency trait. So this is what I told you before. It also implement all currency functionality, including the positive imbalance and negative imbalance. Locks are very similar to reserves, how they are structured. So they are also like a storage item. They are also using an account ID. In this case, what they are storing is balance lock, and they are limited also by max locks. There is a small difference between the balance locks and the reserve data. It's like there is like a reason attribute. So remember when we were looking at the account data, we have like a miscellaneous frozen and the fee frozen. So in this attribute, we are telling what field we want to modify. As reserves, balance lock objects can add, remove to the list from other pallets through the implementation of the traits lockable currency in the pallet balances. The methods will take care of updating accordingly the final MISC frozen and fee frozen attributes from account data. Requires also the currency trait. And at this point, it might be like a bit confusing. What are the difference between reserves and locks, right? Apparently, they just require like a minimum balance. But the main difference is like, whereas reserves are additive, locks amounts overlap to calculate the final lock balance. Let's see an example. So we have here an initial state where an account data associated to an account ID has a free balance of 1,000 tokens, and the rest of values are 0, no reserve, no frozen. Then another pallet through the reservable currency trait executes the reserve method, and it's telling, okay, I want to reserve 10 tokens. Therefore, remember, total amount is free plus reserve. So what will happen is we reserve 10 tokens and we reduce it from the free tokens. So they are not really available to use. And then another pallet comes and say, okay, I want to reserve also. In my case, will be 20. It's like, okay, so we add up to the reserved, and we have the total amount of 30, 10 plus 20, 30, and we reduce from the free balance also. So you can see how they are additive. However, for the logs, we have kind of similar situation. One pallet, in this case, is using the lockable currency trait using the setlock method, and it's telling like it's like for this ID1, I want to lock 10 tokens. The reason is going to be miscellaneous, whatever that is not fee. What will happen? We increase by 10 the miscellaneous frozen. And then another pallet do something similar, or doesn't matter, for another ID, but saying 5. What will happen? Nothing. Will happen nothing, because they overlap. Since 5 is lower than 10, the account data will not be updated in any form. So what this pallet is saying is like, okay, as long as you have at least 5, I'm happy with it. So because there were already locked 10 tokens, there are no changes in the account data. And now my colleague Dominique will explain how this is integrated.
Yeah, so hello. I'm going to talk about the dependencies of the balances palette. And before talking more specifically about the specific palette, I'm going to talk about the notion of coupling, which is very interconnected with the dependencies. So when we talk about dependencies, we talk about coupling. There are two types. Well, this is a notion in general in software engineering, and there are many different types of coupling. data coupling, control coupling, other couplings, but two there are related to Substrate and how we refer to types of dependencies of coupling, and this is loose versus tight coupling. I put here two cute emojis to show that what we want and what is better in the sense of design is loose coupling, and tight is not it's not recommended as good design system. And why is that? I will explain in the second part, where I will mention that Substrate hopefully has thankfully has a loose pallet coupling. So that means more specifically is trade-based dependencies. That makes the system like the design more efficient and more reusable, and that hence is a sign of high quality of software design. Efficient is because the modules are not can be separated. So when we have a lot of the code can be separated based on the logic and what we use it for. So this makes it more efficient, and a lot of coders can program in different pallets without affecting. Oh, sorry, one question. Yeah, the code of in other pallets. So yeah, otherwise, if everything was very tightly coupled, if someone was working on one pallet and this was tightly coupled with another pallet, then it will make a mess in the code. This also reusability. When I say reusability, is that when components are separated, then they can be reused in different places without duplicating code. So the balanced pallet itself, it doesn't have a lot of dependencies, but it has a basic, very important dependency on the frame system for the account, which I will show you in the next slide. But other pallets like staking, voting, vesting, or other pallets that are usually presented in these talks, it's not. Why? Because it's actually this pallet that a lot of other pallets are using. So it's not dependent on other pallets, but it is a dependency for a lot of other pallets. There is also I put it here, the genesis config. I would not call it exactly a dependency, but I mentioned it because it's one of the core parts of setting the state of the chain. And for example, the initial accounts and the initial balances of the accounts. So I thought it was worth mentioning here, and even though it's not the typical dependency that we're used to have in Pallet. The first thing, yeah, which I mentioned, which is a balanced pallet doesn't have any dependency, but it has one with the frame system, and it's very important. It's related with the account store, which is defined in the balances pallet, but its functionality is found in stored map, which is from here's an error. Okay, yeah, in the last pallet, stored map is in frame system, so this is an error. I will have to go. Yeah, so this is one and very important dependency that pallet has. In the next slides, I will explain all the dependencies that not the balance pallet has, but how all the other pallets depend on the balance pallet. So what we said is that it's loosely coupled, and what I mentioned in Substrate, that means it's trade-based dependencies. So that means trades. It's like so the balance pallet implements 5 trades, which is the trade of currency, reservable currency, named reservable, lockable, and imbalance. I think not to explain most of them, but very quickly, the trade of currency deals with the fungible assets. The reservable currency with reserved funds in accounts. Named reservable when we want specific named account to reserve funds. Oh, sorry. Lockable is when we lock funds for staking or voting. And imbalances, the concept that Nacho also mentioned of between TotalIssuance and the balances of accounts. So these trades are implemented in the balances palette, but are used in a lot of other pallets. The first trade, currency, is used in 5 pallets. Election, I just named it here. Election provided multi-phase, nomination pools, pallet staking, etc. I just named them and put them here to show each trade in how many other pallets are used. Reservable currency is used in 20 pallets. So some examples is pallet assets, contracts, democracy, multi-sig, proxy, and there was no space to put them all. But just to show like how many other pallets are using this trade and how important it is. Lockable currency also is used in democracy, conviction is 5 pallets, staking, investing, and election fragment. So these are the dependencies and exactly how are the trades used in other pallets. Okay, sorry. In the next slides, I will show like some examples of the calls that the other pallets are using from these trades. So one typical example is well, the reservable currency trade, which has the 2 calls of reserve and unreserved. It's used in identity and multisig. I think also not to mention an example, but for example, in pallet multisig, when we execute a multisig transaction, we reserve some funds first, and then as soon as the multisig transaction is executed, approved and executed, then these funds are unreserved. So the unreserved call function is used. Another example of how other pallets are using calls of trades of balance pallet is democracy, staking, investing, for example, that are using lockable currency. And they're using specifically the calls of set lock and remove lock. Yeah, typical example that is very, I guess, very common to everyone is in pallet staking, where we lock some funds, and so and to do staking. So the call set lock is called and is used, and as soon as we unstake, like one of the calls is remove lock. Yes. Another way that other pallets are using balances pallet is when types, they define types, but their functionality is defined in the currency trade from the balance pallet. This is very similar to the first example of the dependency of the balance pallet with frame system. But yeah, so I chose the balance of, and this is defined in the type that's defined in pallet contracts, for example, but its functionality is defined by the trade currency, which is implemented in the balance pallet. That's it from the dependencies, and I will pass it to Alex.
So we are gonna go through the demo of this pallet now. So we're gonna check basically all the high-level features that my colleagues explained. We're gonna check first the TotalIssuance. After that, we're gonna check what's the meaning of existential deposit and how it affects the transfers. We're gonna make a listed transfer, and we're gonna just check what's the meaning of balance reserve. And then we're gonna go through the concept of negative imbalance and positive imbalance. Okay, so for that demo, we are running a node template locally. For that node template, we've done some changes. We changed some constant and some values to make it easy for the demo. And we also implement some pallets to allow us to do all the operations we want to do. And we can check that manually here. You can see we have like 6 different accounts that are filled with 10 units each one. So that's means 60 units. And then we also implement the pallet treasury, and we put one we put 1 unit in the pot, so that's 61 units. Another thing we can query here in the balance palette in the constant is the concept of existential deposit. So we go to the balance, we check the constant, and we see the existential deposit. So okay, we wanna try to do a transfer now. We wanna say that Dave wanna do a transfer to Dave. Dave has 10 units in his account, so he wants to do like a 9.5 transfer to Eve. That means that Dave is gonna be with 0.5 unit, that is less than the 1 unit that has the existential deposit. We wanna check why that was. That was because we have selected that option here. That's for security. That means that instead of do a transfer directly, is calling another function that is called transfer keep alive. That what it's actually doing is doing these checks before to allow to do the transfer. It's just gonna check that after the transfer, Dave has still more than 1 unit, more than the existential deposit. So it's not gonna lose the account. Okay, let me open a new tab here so we can see we can do a query in the chain state to check the Dave account. Go to the Dave account and we can see all the information stored in the account info. We can see that his balance is almost 10 units, as we say. It's a bit less because of the fees of that extrinsic that we already tried, and have some information as well. So has the norm set to 1, has the provider set to 1. So what we want to do now is disable this option, the security option. So we want to go through the transfer anyway. We want to do the transfer. We do not care that we are losing this account. So if we do that account, that's gonna mean that Dave is gonna be with 0.5. That is gonna be less than 1 unit. So his account is gonna be deleted from the system. We go to the transfer now. Now it's gonna succeed. Okay, so now succeed, and we can see that Eve has the 9.5 units in his balance, but Dave now has 0. If we check all the information in the chain state, we can see that all the information that was here was set up to 0. That means the account has been repeated. In theory, what should happen now? So the idea was in a normal transfer will be like here you have like 0.5, but because it was below the existential deposit, it was set to 0 and the account was read. Now let's try another interesting transfer, an interesting type of transfer that is called a best transfer. For that, we have installed here, we have implemented here the vesting pallet. This allows us to send a best transfer. So in that case, for example, a best transfer is a transfer that you send money to another account, but it's going to be locked for a certain amount of time. In that case, we want to send from Bob to Dave, we want to send two units. And we want, let's see the blocks. Now we are around the 300 blocks. So we want that each block is 0.05 amount is released each block. So we put here 0.05. And let's say if we want that to start in the block 310. We are now in the block 300. Let's put a bit less. We want that to start in a block 306. So we submit the transaction. So the transfer goes through. So now we can see Bob has like 8 units, a bit less because of the fees, but almost 8 units. And we'll see now that I sent to Dave. So Dave has 2 units now. He has just 0.05 transferable units, and he has like almost 2 unit logs. That was because when we send the transfer was already in the 306 that we set up. So this amount is vested, so it's increasing 0.05 each block happened. So we now has increased 0.05 more. So that means that these 3 now Dave can release this 0.4. So we can go here and unlock this vest amount. What this function is gonna do is call to the vesting pallet and do the unlock function. to go through it. And then we will see here in transferable, we have like almost 0.5 units. And we don't have now two unit log, we just have 1.45. And now we want to see what the meaning, that's the log, that's where you have a log balance. Now we want to see what's the meaning of have a reserve balance. So for that, we've implemented another external pallet. We implement the identity pallet that allows someone to register an identity. So let's see, we want now Charlie to set an identity for himself. And what he's gonna do, Charlie, is just change his name. Instead of Charlie, he wants to be Alex. To do that operation, to do the identity pallet, the transaction goes through already. You need to bond some token. So you have to put a deposit to be able to set an identity. In that case, when we implement this pallet here in the code, that's gonna be for the identity pallet is gonna be for another season. But just to see that quickly, we set up that the basic deposit that we need to set an account is one unit, and for each field that we fill, 0.25. So in that case, we have Charlie or Alex here have deposit 1.25 units to set up his identity. So we go here and we can see now that it has reserved 1.25 units. So he cannot send now his amount because it's bonded into the system. Okay, so what we want to simulate now is that we did something wrong, something with pseudo power, something with a pseudo privilege, can go and kill our identity. So he can go here and say that, okay, Charlie, we are gonna kill your identity. So the deposit that you have already put, this 1.5 units, is gonna be slashed. So we submit the pseudo operation. And we can see now here, so do that. Gonna see that now it's Charlie again, it's not called Alex, and the 1.25 unit that was reserved has already been lost. So it's not 1.5, it's 8.7. When we implemented this pallet here, the pallet identity, we said that when there is a slash, when there is a slash in the reserve, it doesn't pour, it goes to the treasury. So we can go to the treasury now, and where we have like 1 unit, now we have 2.20, almost 2.25, a bit less because of the fees. Okay, so what we want to test now after this reserve, we want to test what's happening when there is a negative imbalance and a positive imbalance. So we're gonna make a proposal here with the treasury pallet. So let's say Bob wants to propose that Charlie receive 10 units from the treasury, and to do that, Bob has to bond the 10% of what he's asking for. So he's asking for 10 units, so he has to bond one unit of our token. So Bob submits the proposal. It goes through, and we can see now that Bob has like 1 unit reserve and still some transferable. Okay, so what's happened? So what's a negative imbalance? Negative imbalance, in that case, we set up that when there is a slash in the treasury, it doesn't go back to the treasury. We set up here in the implementation that it burns this bond. So what that means is that if we go here and Bob goes to the treasury and he rejects the proposal, he's gonna lose that unit that is bond. So we are taking a balance from someone and we are deleting that balance. So that means that's the example of a negative imbalance. So let's do a quick check here in the chain state. Let's check the total issuance now. The total issuance of the system is 60.4. A bit less than 61 because we have delayed an account before and some transaction fees. But remember that number, 60.4. So now we go. Bob gonna reject his proposal, so that means he's gonna lose his unit. So we are gonna delete one unit from the. We're gonna burn one unit. We are gonna delete one unit from the system. So what the balance pallet does is it balances the total issuance. So it's the total issuance, and now instead of 60.4, it's 59.4. Now we can try the opposite. We will do like a positive imbalance. So that's when someone with pseudo powers can go to the balance pallet and can set a balance. So can introduce new tokens into the system. So he can go and pick Ferdi. That was an account with zero units. And we're going to send Ferdi, we're going to create 10 tokens for the Ferdi balance. Remember now that the total issuance is 59. So we create that, we set this balance for Ferdi. We'll see that Ferdi now has 10 units. And we'll query again the total issuance, and now instead of 59, it's 69.4. So that what happened here was like a positive imbalance. Okay. So yeah, that was all for the demo. I was as well on the first part of the presentation. We're gonna just have now a time for a Q&A, and then we're gonna go more in deep, more technical, and Nacho is gonna go through the code.
Okay, so we are gonna see a couple of things. The first one is how the pallet is configured in Polkadot. And the other one is how other pallets are coupled with pallet balances. Let's go with the first one. So here we have the pallet balances configuration. We'll go through all of their types. The first one, it's the balance type. Yeah, as I was saying, not much to say about this type. Maybe just to mention that it should be like at least like a 32-bit unsigned. The next one, it's, well, in this case, I think it's unsigned 128 in the case of Polkadot. Then we have the type dust removal. So this is a type that is used in the pallet balances to perform some action when we rip an account. So it requires this trade, that on unbalance trade. So basically what we do is that when we rip an account and there is some dust that we want to remove, actually this is used in this struct, in the dust cleaner, that it's returned when an account is stripped. Then we'll perform an action to do something with that imbalance, negative imbalance, right, after ripping the account. Actually, we are doing nothing. So basically what it means is like we are burning the dust from the system. Next type, it's events. Not much to say about this one. It's common to a lot of pallets. Next one is the existential deposits. I already talked about this one. We can see here in Polkadot how it's set to be 100 cents. The next one is the account store. Okay, so the account store, it's where the interconnection, the coupling happens between the system, the frame system pallet and the balances pallet. You can see here that everything is asking is, okay, give me an struct that implements this trade, the store map. So for Polkadot, what we are doing is like feeding this type with the system, with the frame system pallet. So we should expect the pallet system to implement this trade, right? So let's take a look. Store map, right? Yeah, here we go. Here is where the implementation of the store map trade happens for the frame system pallet. What's happening here? To summarize, what's happening here is this trade is modifying the account storage item. Okay. What's the account storage item? So remember, we said that, and you saw it also in the demo, that the balances are not stored in the pallet balances, are stored in the system. So if we go to the accounts storage item, okay, here you see that it's like a storage map, like a key value. And what we are saving here is like account info, an account info that depends on an account data on this generic. So if we take a look to the extract account info, what it's like really like what it's actually being saved, we see that it has some important information for the system, including the nonce. And here we have our account data. Here is all the balances data. It's saved in this attribute in data. Let's keep walking through the configuration. We have the max logs. Remember when I was talking about the logs? But it's like also a storage item that it's like a list, okay, of the balance log extracts. So it's using like a bounded back with max logs. Well, what it means is like, okay, when you start like adding new logs in the balance palette, it cannot like surpass, go beyond these max logs. That right now it's set to 50 in Polkadot. Similar for max reserves. Reserve identifier, this is a pretty simple one. This is basically used when we want to give an ID for the reserves and the logs. Here, what it's telling you basically is like, okay, use a string that is longer than 8 characters. And then we have the type weight info. Not much to say about that. Also common to a lot of pallets. Basically, what we are doing here is like injecting all the weights for the pallet balances methods. We'll go through the second section, how other parts are coupled with the pallet balances. And for that, we'll take a look at the pallet vesting. Here it is. Okay, so you can see here, in this state, currency, we are using the balances palette. Okay, let's take a look at the vesting palette, to its configuration, and we see that this type requires a struct that implements the lockable currency. And therefore, we should expect that the balances palette it's implementing, well, we know it does, but let's take a look. Implementing this trait. Here it is. Here you can see like the methods we talked about previously. Set log, standard log, remove log. Okay. So also, if it's using this trait, we are also expecting that at some point it's using one of their methods. So let's look at it. Let's say set log, and here it is exactly. It's using it during the build configuration, and it also it's also being used here during the write log method. What else? And I think that's it.